Welcome to the AI Coach by Anil Nathu. Have you ever been there?
Yeah.
Interacting with an AI language model, maybe trying to get some quick, critical info, and it gives you this response. Sounds totally confident, really authoritative, only for you to figure out later it was completely, utterly made up.
Oh, absolutely. We actually have a term for that in the AI community. We call them hallucinations.
Yeah.
And honestly, they represent one of the biggest, most persistent challenges, even for the really advanced AI systems we have today. It's a bit like having this brilliant, super articulate friend who knows a ton, but
Yeah.
sometimes they just invent facts
Right.
out of thin air.
Exactly. And it's not just the making things up part, is it?
Right.
Another thing you might notice is, well, while these models are incredibly smart in many ways, their knowledge gets old, fast. They're trained on this massive snapshot of data, right? Frozen at a particular moment. But the world keeps moving, things change, and the AI just gets left behind.
Yeah, that static knowledge base, it's a real hurdle, especially when you need information that's current, like right now, whether that's breaking news or the absolute latest scientific finding.
Well, today we are diving deep into a really powerful solution designed to tackle exactly those problems. It's called Retrieval-Augmented Generation, or RAGE for short. Think of it like this. Imagine giving an AI model its own super smart research assistant, one that can access this huge, constantly updated library like a dynamic, real-time knowledge source while it's answering your questions. It's pretty transformative for making AI more reliable.
It really is. RA fundamentally changes how these large language models operate. It pushes them beyond just recalling stuff from their training data. Instead, it enables them to actively synthesize information in an informed way by pulling from external, verifiable sources.
So our mission for this deep dive is to really unpack an incredibly insightful paper. It's titled Enhancing Retrieval-Augmented Generation, a study of best practices. The authors are Siran, Linus, Stenzel, Carsten Eickhoff, and Seyed Bahrainian from the University of Tübingen. And what they did was systematically investigate 9 key factors, things that really influence how well these RA systems actually work. And what's super exciting is they even introduced some genuinely novel techniques that are pushing the boundaries of what RA can do.
Yeah, what's so valuable about this paper is that it doesn't just describe RAG in theory. It meticulously takes it apart. It looks at the components, different ways you can set them up, and it aims to figure out empirically what really drives performance. And crucially, to nail down some best practices, which honestly gives a much-needed solid foundation for anyone out there looking to build or, just improve these RA systems.
Exactly. So our goal for you, our listener, is to give you a clear, actionable understanding of what truly makes a RAG system shine. We're going to explore which parts have the biggest impact, which design choices tend to lead to the most accurate, most relevant answers, and maybe just as important, which approaches might be, well, surprisingly less effective than you'd think. By the end of this, you should have practical, evidence-based insights for developing more reliable, high-performing RAG frameworks, for all sorts of real-world situations. And this commitment, this idea of constantly learning, integrating the latest breakthroughs, and turning them into practical knowledge, that's really a core principle behind the AI Coach by Anil Nathu. Okay, so let's go conversation. Why RA in the first place? What were those inherent problems, those limitations with the traditional standalone language models that RGAG was actually built to solve?
Well, the main limitation really comes down to how these models are fundamentally built. Think about models like GPT or BERT, right? They're trained on these absolutely massive data sets, but those data sets are essentially snapshots, information capture up to a certain point in time. So their knowledge is, by its very nature, static. They don't inherently have like a live connection to the internet or any other source that's constantly being updated.
Right. It's kind of like training a brilliant student using only an encyclopedia set printed 5 years ago.
Yeah.
They'd be incredibly knowledgeable, sure, about everything in those books, could probably explain things really eloquently within that scope, but ask them about, say, last week's big global event or the latest medical breakthrough. They'd either just not know, or maybe worse, confidently make something up that just sounds plausible.
Exactly. And that leads us straight back to those infamous hallucinations you mentioned earlier. It's the term we use when these language models generate information that's factually wrong, illogical, maybe even just nonsensical, but often with this surprising level of confidence. See, they aren't thinking or knowing like humans do. They're essentially predicting the next most likely word based on statistical patterns they learned during training. So if their training data doesn't have a clear, factual answer for your specific question, they'll still try to complete the sentence in the most statistically probable way. And often that results in stuff that looks right but is totally fabricated.
So it's not like the AI is deliberately lying or anything. It's just a side effect of how it works predicting the next word. There's no solid fact in its memory. It fills the gap with the most likely sounding fiction. And speaking of that training data, constantly retraining these huge models with new information sounds like a massive operational headache.
Oh, it absolutely is. It's a monumental challenge. Updating these colossal models, often with hundreds of billions of parameters, it's incredibly resource intensive, massive computing power, huge costs, and it's highly inefficient. Imagine having to basically retrain a whole data center's worth of computers every time there's a major world event or a new product launch or a big scientific paper comes out. For fields that change rapidly like tech, medicine, even just current events, it's simply impractical and, frankly, economically unsustainable.
Okay, so that perfectly sets the stage for RX stepping in as this, well, elegant and powerful solution. What's the absolute core concept behind RX? What makes it such a game changer?
At its heart, our systems work by integrating external knowledge sources during the inference process. What that means is when the model is actually generating a response, it's not only relying on its stored static training data. Instead, it actively looks up relevant information from a separate, often dynamic knowledge base, like a curated collection of documents or data, and then it uses that retrieved information to inform and, importantly, ground its final output. This was a really significant leap forward.
Wow. So the model isn't just recalling facts it memorized ages ago. It's actively doing research as it's composing the answer. That feels like a massive shift in how AI works. What are the key benefits this unlocks for, users and developers?
The benefits are really substantial. First, and maybe most obviously, RF gives you access to up-to-date information. If your knowledge base is kept current, the model's answers will reflect the latest data. Second, and this is crucial, it leads to significantly enhanced factual accuracy and reliability. By grounding responses in actual verifiable external info, RH drastically cuts down on those hallucinations we talked about.
Okay, that makes sense. Less guessing, more fact-checking.
Exactly. Third, it ensures contextual relevance. So it can provide really specific, tailored information even for complex or niche questions, instead of just giving generic answers.
And I find this next point really compelling. RAG can essentially turn these general-purpose language models into actual specialists.
Absolutely. Think about it. A standard large language model, an LLM, it's a generalist. It knows a little bit about a lot of things, but often the knowledge is kind of shallow. But if you integrate a specific domain-focused knowledge base, maybe all the latest research papers in a field, or a company's internal technical docs, or a huge library of legal cases, well, a RRAD model can equip that generalist LLM to function like a highly informed expert in that specific area. And this ability to provide really relevant, accurate guidance across different domains by tapping into curated knowledge, that's a core idea behind services like the AI Touch by Anil Nafu.
That's a fantastic analogy. It really clicks. It's like taking our brilliant scholar, the one with the slightly spotty memory, and giving them instant access to this enormous, constantly updated, perfectly organized library, and telling them, hey, check the library every time someone asks you something.
Yeah.
Their answers wouldn't just be eloquent. They'd always be accurate and current. That really captures the power of RAG.
It does, and while RAG is clearly very promising, the paper we're digging into today highlights a really critical point. Despite RAG becoming more popular and its advantages being pretty clear, the actual best practices for designing and optimizing these systems are still not well understood. There's been a lot of innovation, yes, but maybe less systematic empirical study to really figure out what makes them tick and which design choices give the best results. And that's exactly the gap this paper tries to fill through really rigorous investigation.
Right. Now that we've got a solid handle on the why behind RAG, let's dig into the how. How are these RAG systems actually put together? What's the basic architecture look like? And importantly, how did this research team go about testing them so rigorously to uncover these best practices? Maybe we can break down the core parts simply.
Definitely. So a RAI system, at least as explored in this paper, generally involves three main modules. They all work together to take your question, find information, and generate an informed answer.
Okay, module 1. The paper calls it the query expansion module. What's its job in this whole process?
Okay, imagine you're asking a question to a highly specialized librarian. Your first attempt at phrasing it might be a bit too narrow, right? Or maybe too specific. You might miss out on some broader but still really relevant information. The query expansion module. Its job is basically to broaden that initial search. It takes your original question, and using a smaller, quicker language model in this case, they use something like a fine-tuned FLAN T5 model. It generates a bunch of related keywords or slightly different versions of your query.
Ah, okay. So it's like telling that librarian your first question, and they immediately fire back. Okay, you might also want to try searching for this term, or maybe phrase it like this. It helps cast a wider net initially.
Exactly. It makes sure the search is more thorough, more comprehensive right from the start. It's based on established ideas from information retrieval, start broad, then get more specific.
Makes sense. Okay, next up is the retrieval module. This sounds like where the actual heavy lifting happens, the library lookup part where it fetches the relevant stuff.
That's spot on. The retrieval module is all about efficiently finding the most relevant pieces of information from that huge knowledge base, our digital library. So how it works is, first, the documents in that knowledge base get broken down into smaller bits, smaller sections. We call these chunks. Then these chunks get converted into numerical embeddings.
Okay, embeddings. I hear that term a lot. Can you break that down simply? What are they?
Sure. Think of embeddings as mathematical fingerprints for text. They capture the semantic meaning of a piece of text, not just the keywords. So an embedding model, often something called a sentence transformer, turns these chunks of text or even individual sentences into these lists of numbers, these vectors, in a high-dimensional space. And the key idea is that texts with similar meanings will have embeddings that are mathematically close to each other in that space. Your original question, that gets turned into an embedding too. Then a super fast search engine, they use something called FES, which is designed specifically for this kind of similarity, searching with lots of vectors, quickly compares your query's embedding to all the document chunk embeddings. And that's how it finds the chunks whose meanings are most similar and therefore most relevant to your question.
Wow. So it's comparing meaning, not just words, and doing it incredibly fast across potentially millions of chunks. That's really clever. And the paper mentions this isn't just a single lookup, right? They used a multi-step retrieval process.
Yes, the RAG systems they tested often used a pretty sophisticated multi-step approach. Step 1 usually involves that initial retrieval using the expanded queries we just talked about, plus your original one that casts the wide net. Step 2 then refines that search. It uses just your original query to re-rank the documents found in Step 1, narrowing it down to the most relevant documents.
Okay, broad search, then refine. Makes sense. But then there was a third step they introduced, something called focus mode. That sounds like it's aiming for even more precision.
Focus mode is definitely one of their more innovative contributions here. So instead of just stopping at finding the most relevant documents or chunks, focus mode takes those relevant documents, splits them down even further into individual sentences, and then it retrieves only the absolute most relevant sentences based on your original question.
Whoa. Okay, so it's not just finding the right book or the right page.
Yeah.
It's finding the exact specific sentences on that page that matter most. That must cut down massively on irrelevant noise and give the language model a much clearer signal to work with, right?
That's exactly the idea. Provide highly targeted, precise context. And that leads us to the final piece, the text generation module.
Right, this is where the magic happens, where the AI actually crafts the answer.
Precisely. This is where the main large language model, the core AI brain, if you like, takes your original question, plus all that carefully retrieved and filtered context, whether it's chunks or those specific sentences from focus mode, and it synthesizes all of that information to produce a coherent, accurate, and relevant answer. And interestingly, in some of the advanced setups they tested, particularly when looking at something called retrieval stride, that retrieved context could even be updated dynamically, like while the model is still generating the answer based on what it's already written.
That's fascinating, constantly refining its knowledge base, mid-thought almost. Okay, so the study looked at 9 specific questions about how to optimize all this, which we'll get into individually. But first, how do they actually test all these variations? They used something called an ablation study. Can you explain that simply?
Yeah, absolutely. An ablation study is a really standard, rigorous scientific method. Imagine a chef trying to perfect a complex recipe. They might change just one ingredient, a pinch more salt, a different type of flour, while keeping everything else exactly the same, to see precisely how that one change affects the final dish. That's what the researchers did here. They systematically changed one specific part or setting of the RE system at a time, like the chunk size or the type of prompt used, while keeping everything else absolutely constant. This lets you isolate the impact of that single change. You can see clearly if it helps, hurts, or does nothing to the performance. It gives you that cause and effect understanding.
That makes total sense. A really methodical way to untangle a complex system like RAG. And they evaluated these different RE setups using two well-known datasets. The first one was called Truthful QA.
Right. Truthful QA is pretty unique. It's designed specifically to test a model's ability to be, well, truthful. It challenges the models to avoid common human misconceptions or widely believed falsehoods. For example, a classic question might be something like, what happens if you eat watermelon seeds? The common but wrong myth is you'll grow watermelons in your stomach, right? Truthful QA tests if the model can cut through that popular myth and give the actual factual answer, which is, they just pass through your system harmlessly.
Huh. Right, so it's not just testing if the AI knows stuff, but if it can resist popular misinformation, almost like a test of wisdom or at least critical filtering, not just knowledge recall. That sounds tough.
It is a high bar. The second data set they used was MMLU. That stands for Massive Multitask Language Understanding.
Okay, the name alone sounds pretty intense. What's MMLU testing?
It is intense. MMLU evaluates a model's understanding across a huge range of specialized academic and professional subjects. We're talking 57 different subjects. Things like abstract math, physics, but also ethics, law, history. Really diverse. A typical question might be something specific like, an integer overflow occurs when, requiring detailed computer science knowledge. So it's designed to really gauge the depth of a model's understanding in these very nuanced domain-specific areas. Kind of like sitting a comprehensive exam covering dozens of different university courses.
A very good analogy. And the knowledge base they used, the digital library for the Raji systems, was drawn from Wikipedia Vital Articles,
Right.
specifically levels 3 and 4.
Yeah, that was a strategic choice. Wikipedia Vital Articles are curated to represent a broad foundational understanding of human knowledge. Levels 3 and 4 offer a good mix, comprehensive enough but still manageable for experiments. Plus, it's available in multiple languages, which they also tested.
Okay, and finally, how did they measure success? It wasn't just one score, right? They used a whole suite of different evaluation metrics. Why was that important?
Using multiple metrics is absolutely crucial. It gives you a much more holistic picture of performance. Relying on just one metric can sometimes give you a skewed or incomplete view. So they used, first, RUG. That stands for Recall-Oriented Understudy for Gisting Evaluation. Basically, it measures how much the words in the AI's answer overlap with the words in a human-written reference answer. It looks at single words, pairs of words, and longer matching sequences. Good for checking lexical similarity.
Okay, word overlap. What else?
Then there's embedding cosine similarity. This one measures how similar the meaning or the semantic content of the generated text is to the reference answer, even if the exact words are different. It gets closer to capturing if the AI understood the concept.
Right, meaning similarity. Got it.
Third, MAUVE. This one compares the overall statistical properties and style of the AI's text to human-written text. It tries to capture things like, is the text diverse? Is it coherent? Does it feel like something a human would write, beyond just being factually right?
Okay, so style and distribution. And the last one sounds really important, fact score.
Yes, fact score is critical because it directly evaluates the factuality of the answers. It works by breaking down the AI's response into individual atomic facts or claims. Then it programmatically checks if those individual facts are actually supported by the retrieved source documents or known reliable facts. And interestingly, to do this check, it actually uses another LLM, like GPT 3.5 Turbo, essentially as a sophisticated fact checker or scorer.
Wow, using an AI to score another AI's factuality. That's pretty meta, but it makes sense for handling complex claims. So, taken together, these metrics give a really rounded view, fluency, meaning style, and crucially, factual accuracy. It's not just about sounding good, it's about being right. And this kind of robust evaluation, using multiple angles to ensure the insights are reliable. That's exactly the kind of rigorous approach we value and use at the AI Coach by Anil Nathu. All right, let's get to the really juicy part now, the actual findings. We're going to dive into those 9 specific factors the study looked at, what really makes RAG tick, and maybe what doesn't. First up, the size of the underlying large language model. There's a common assumption, right, that bigger is always better for the base LLM in a RAG system.
Yeah, that's a very natural thought. You'd figure a more powerful engine underneath would always lead to better results overall. So the study compared a smaller 7 billion parameter model against a much larger 45 billion parameter one. And Well, generally speaking, yes. The larger LLM did outperform the smaller one. This was especially clear on that general knowledge dataset, Truthful QA. The 45B model showed a pretty significant improvement across different metrics compared to the 7B baseline.
Okay, so for broad general knowledge questions, having a bigger brain, or at least a larger model, definitely seems to help.
Exactly. And this is where it gets nuanced. The improvements were, as the paper puts it, less notable when it came to the specialized tasks, particularly in that MMLU dataset. This suggests that maybe there are diminishing returns after a certain point, or maybe sheer size isn't the only thing that matters, or even the main thing when you're dealing with really specialized knowledge. Just making the model bigger might not proportionally improve its grasp of, say, advanced physics if the retrieval part isn't giving it exactly the right, highly specific information it needs.
That's a really important practical point then. For developers or organizations using RJ, while a more powerful base model can definitely be beneficial, just pouring resources into bigger and bigger models might not give you the best bang for your buck for every single application, especially if it's in a very specific niche. It sounds like finding the right balance and maybe optimizing other parts of the RJ system is key for your AI coach, depending on what you need it to do.
Absolutely. Okay, next factor. Prompt design. This is all about how you instruct the model, the specific words you use to tell it what to do. Can subtle differences in how you phrase your prompt really make a big difference in RJ's performance?
This is something I think a lot of us who use AI regularly kind of feel intuitively, right? You tweak a prompt slightly, and suddenly the output changes dramatically. It's great to see it tested systematically.
And the research strongly confirms this intuition. Prompt design is absolutely crucial. They tested different styles of prompts. Some were designed to be helpful, like explicitly telling the model, you are a truthful expert question-answering bot. Others were intentionally designed to be adversarial or misleading. Things like, you are an imaginative storytelling bot. Or even, get this, you are a friendly dog.
Wait, they told it to be a friendly dog. That's brilliant. But it really highlights how literally these models take their instructions, doesn't it? They'll try to be a dog if you tell them to.
Exactly. And perhaps unsurprisingly, the helpful prompts consistently and significantly outperformed the adversarial ones across all the different ways they measured success. It just underscores that even slight changes in wording can profoundly affect how the model interprets its job and, critically, how it uses the information it retrieves, the adversarial prompts. They consistently led to worse performance, often giving unhelpful or just plain weird answers because the model was actively trying not to be a helpful, factual bot.
That's such a powerful takeaway. For anyone building or even just using AI systems, carefully crafting those instructions, those prompts for your AI coach, it's probably one of the most cost-effective and high-impact things you can do to improve the quality of its answers. Clear instructions lead to clear answers, often the lowest hanging fruit.
Couldn't agree more. Okay, next let's look at two related factors. The size of the document chunks retrieved and the overall size of the knowledge base itself. First, chunk size. How does the size of those pieces of text pulled from the knowledge base affect the final answer quality?
Yeah, this feels like a classic trade-off designers face. Make the chunks too small, maybe you lose important surrounding context. Make them too big, you might flood the model with irrelevant details, just noise.
Right. And the study's findings here were quite interesting. They actually found minimal performance differences across the various chunk sizes they tested, ranging from 48 tokens up to 192 tokens. While the largest chunks, the 192 token ones, did show some very slight improvements on certain metrics, the differences were really minor overall and not statistically significant. This suggests that the impact of chunk size, at least within this range, might not be as critical a tuning knob as some might have thought.
That's actually kind of a relief for people designing these systems. It means maybe there's a wider sweet spot than we assumed. You don't necessarily have to agonize over getting the chunk size perfect down to the last token. Frees you up to focus on other things that might matter more.
Precisely. Now, related to that is the sheer size of the knowledge base itself. How does the total number of documents you put in your digital library affect the RBAC system's performance?
Again, intuition, or maybe just a more is always better kind of thinking, might suggest that just adding more and more documents should make the RH system smarter, right? More information equals better answers.
Well, this is where the findings were particularly insightful and maybe a bit counterintuitive for some. The study found, again, minimal performance differences when they compared smaller knowledge bases like 1,000 documents versus much larger ones with 10,000 documents. They even tested retrieving just 2 documents versus retrieving 5 documents for a given query, and found no statistically significant improvements from retrieving more.
Wow, okay, that is surprising. So just dumping more data into the knowledge ghost doesn't automatically make the RAG system better. Why do you think that is? Does too much irrelevant stuff maybe just confuse it?
That's an excellent question, and it gets right to the heart of it. The researchers basically suggest that beyond a certain point, the extra documents might just be irrelevant or redundant for answering the specific questions being asked. They add noise, essentially, without adding valuable signal. Think about it like having a giant library, but half the new books are duplicates, or they're on completely unrelated topics. The extra volume doesn't help your research, it just makes it harder to find what you actually need.
So the big takeaway here is massive.
Right.
Don't just throw all your data in and hope for the best. The quality, the relevance, and maybe even the organization of the documents in your knowledge base are far more important than just the sheer number of documents.
Huh.
Your AI coach needs the right facts, precisely relevant facts, not just more facts. Really highlights the importance of careful data curation.
Absolutely critical. Okay, next factor, retrieval stride. This applies to those more advanced RA systems we mentioned, the ones that can dynamically update their context while they're generating an answer. The question is, how often should those context documents be refreshed or swapped out?
Right. This is the system that's kind of reevaluating what it needs to know as it goes along, like having an editor constantly feeding it new reference notes. You'd think more frequent updates would be better, right? Keep the info super fresh.
That was my intuition too, but this was a genuinely surprising result. The study found that reducing the stride, which means more frequent context updates, actually lowered performance across the board. Conversely, less frequent updates, meaning larger strides, helped preserve context stability, and that led to better coherence and relevance in the final generated text.
Whoa, okay. That is really counterintuitive. I definitely would have guessed more frequent, better. Why do you think having that stable context turned out to be more helpful?
It's a key finding that challenges some earlier ideas. Some previous work, often based on a metric called perplexity, had suggested smaller strides were better. But this paper, aligning with some other recent studies, points out that perplexity, which measures how well a model predicts the next word, doesn't always line up well with how humans judge the actual quality of the response. A more stable context probably allows the LLM to build a more coherent train of thought, to integrate the information more smoothly over a sentence or paragraph, rather than constantly having its focus shifted or having to reconcile potentially conflicting new bits of information midstream.
That makes a lot of sense when you put it that way. So the practical takeaway is, constantly hitting refresh on the context isn't automatically the best approach. Sometimes, letting the model work with a stable, coherent set of information for a bit longer leads to better, smoother, and ultimately more reliable answers from your AI coach. Less interruption can mean better flow.
Well put. Okay, next up, query expansion. Does adding those related terms to the user's initial query, like our helpful librarian suggesting other keywords, actually improve the model's precision or ability to find the best documents?
Yeah, as you said, it sounds like a solid principle from information retrieval, casting a wider net. But how did it actually perform in their tests?
Well, in this specific study, query expansion resulted in only marginal performance gains. While it did show some slight improvements on the truthful QA dataset as they increased the number of expansion keywords, the overall impact wasn't huge or statistically significant across all the tasks they tested.
So, a potentially good idea in theory, and maybe helpful sometimes, but perhaps less impactful in practice for these particular tests compared to other factors they looked at.
Exactly. The researchers suggested that for the specific tasks they evaluated, the system was often able to find the most relevant documents even without that explicit query expansion step. So its impact might be quite task-dependent. It's still a valid technique, but maybe not the first lever you'd pull for major optimization in every single RAG setup for the AI coach, unless your users consistently ask very, very narrow questions.
Okay, now for the part that sounds really exciting, the paper introduced two novel approaches that seem to deliver significant performance boosts, real standouts. First, let's talk about Contrastive In-Context Learning, or ICL. This is about learning from both good and bad examples. How does showing the model demonstrations of both correct and incorrect answers influence how RT generates text?
Yeah, this was a truly novel and profoundly impactful contribution from the paper. So instead of just giving the model background facts to use, you provide it with demonstration examples. Each example includes a question, its correct answer, and this is the crucial part one, or more carefully chosen incorrect answer.
Wait, hang on. You're not just showing it the right way to answer, you're also explicitly showing it the wrong way. That feels
that different.
almost counterintuitive to how we usually think about teaching AI.
That's exactly why it's so powerful. This contrastive method helps the model learn to differentiate, to distinguish between what makes an answer correct versus incorrect, or what makes a statement truthful versus a hallucination. It's like teaching a student not just the right formula, but also showing them common mistakes people make and explaining why those mistakes are wrong. It explicitly guides the model's reasoning process towards accuracy. And the findings, they were genuinely remarkable. This approach led to significant improvements across all metrics. Just to give you a couple of numbers, they saw a nearly 4% increase in RUGEL on truthful QA and almost a 3% improvement in MAUVE on MMLU just by including these contrastive examples.
Wow, those are really substantial, measurable gains. So this technique genuinely helps the model become better at telling fact from fiction, leading to much more accurate and contextually sound answers because it's explicitly learned what not to do. That sounds like a genuine game changer.
It absolutely feels like one. The practical takeaway is huge. This is a powerful, advanced technique for training your AI coach to be more discerning, more factually precise, and much more robust against making things up. It's like building internal guardrails by showing it the pitfalls to avoid. It really hones its ability to generate trustworthy responses.
Okay, that's contrastive ICL. The second novel approach that really stood out was focus mode. This seems to be all about precision, getting just the essentials rather than volume in the retrieval step. Does focusing on only a few highly relevant sentences instead of whole document chunks really sharpen RG's answers?
This was another really clever contribution. As we touched on when talking about the architecture, focus mode works differently. Instead of grabbing whole chunks, it first identifies the most relevant documents, then breaks those documents down into individual sentences. It ranks those sentences by relevance to the query, and then feeds only the top-ranked, most essential sentences to the main LLM. So it's like performing surgery. Surgically extracting just the precise nuggets of information the LLM needs and cutting away all the surrounding potentially irrelevant stuff.
That's exactly the goal.
Yeah.
And the findings strongly supported this approach, generally increasing the number of relevant sentences provided after this fine-grained filtering improved performance. This was especially noticeable on common-sense tasks like truthful QA, one specific setup, filtering 80 initial docs down to 80 key sentences, saw a solid 1.65% gain in ROGEL. And for the specialized MMLU tasks, focusing on relevant sentences also significantly boosted response quality, improving metrics like MAUVE and embedding cosine similarity in different configurations.
This really hammers home that idea of quality over quantity again, doesn't it? Even within the retrieve context itself. This approach basically cuts down the noise, gives the model this highly targeted, super concise context, striking a much better balance between getting enough information and not getting overwhelmed. Precisely. The practical takeaway is crystal clear. Intelligent surgical filtering matters. Giving your AI coach exactly the information it needs, the essential nuggets, rather than the whole haystack, is crucial for getting back concise, accurate, and highly relevant answers. It really prioritizes that semantic focus.
Okay, finally, let's touch on something that could be a real challenge for many applications aiming for global reach: the multilingual aspect. Does putting documents in multiple languages into the knowledge base affect how the RAG system responds, especially if you want the answer in a specific language like English?
This is a super important question for anyone building AI for international use, and the study's findings here were quite stark. When they added French and German documents into the knowledge base alongside the English ones, the overall performance and relevance of the RAG system actually declined compared to when it only had English documents. And this drop happened even when they explicitly told the model, please respond in English.
Wow. So mixing languages in the knowledge source actually made things worse, at least in their setup, even when the output language was supposed to be consistent. That's a significant hurdle.
It really is. The model seemed to struggle to effectively synthesize or reconcile information coming from different languages within that configuration. The challenge likely stems from the added complexity. The model has to process, understand, and then integrate facts presented in different linguistic structures, especially tricky if the question is in one language and the relevant retrieved info is in another. It's more than just translation. It's about deep cross-lingual understanding and ensuring factual consistency across languages.
That's a really critical practical takeaway then. While the idea of having this comprehensive multilingual knowledge base sounds great for reaching more people, it can add significant complexity. And it might even hurt performance if the RRK system isn't specifically and robustly designed from the ground up to handle that sophisticated cross-language understanding and synthesis. It sounds like an area where the AI coach, and AI generally, still needs more advanced tools and dedicated research to really bridge those linguistic gaps effectively. Okay, so pulling all these fascinating threads together, let's talk about the overall impact, especially on factuality, which is just so critical if we want AI we can actually rely on. Did this study definitively confirm that ROG delivers on its core promise of fixing some of the big problems with traditional LLMs?
Oh, absolutely, without a doubt. The study clearly confirms that RAG systems significantly enhance factual accuracy compared to just using the base large language model on its own without any external retrieval. They had a baseline model they called WAR-RAG, meaning the LLM without the RAG component. And that baseline consistently and significantly underperformed across all the factuality tests. So this gives really solid empirical proof that RxC fundamentally works in reducing hallucinations and boosting truthfulness.
That's fantastic confirmation. ARG really does help tackle those hallucination and truthfulness issues. A huge win for dependable AI. And within the different ARG setups they tested, which ones came out on top specifically for factuality? Looking particularly at that fact score metric, the one designed to really measure accuracy.
Right. For pure factuality, Contrastive In-Context Learning, specifically the ICL-1D Plus version, emerged as the clear winner. It achieved the highest fact score on both the general knowledge truthful QA dataset and the specialized MMLU dataset. That really highlights just how powerful that technique is for ensuring factual precision. Teaching the model by showing it both right and wrong examples truly paid off in terms of making its answers more accurate and less prone to making stuff up.
A really strong endorsement for that novel technique. What else performed particularly well on the factuality front?
Focus mode also did very well, especially the configuration retrieving 120 initial documents and filtering down to 120 key sentences, 120.120s. That one ranks second highest on the specialized MMLU dataset for factuality. It really demonstrates how effective that precise sentence-level retrieval can be, particularly in those complex specialized domains where getting the exact detail right is crucial. And interestingly, query expansion, Expandel, also showed strong factuality performance, specifically on truthful QA, suggesting that for common sense reasoning, broadening the search initially can sometimes help uncover a wider range of relevant facts needed for a truthful answer.
Okay, so contrastive learning and focus mode really shine for accuracy. And beyond just the numbers, the paper gave some examples, right? Some qualitative insights into how these top models actually behaved. What did those examples show?
Yeah, those qualitative examples were really illuminating. For the common sense questions on truthful QA, the configurations using contrastive ICL and focus mode tended to provide concise, factual responses that directly addressed the question. Crucially, they avoided being overly wordy or including irrelevant details, a common problem with less optimized models. They got straight to the point, accurately.
And what about for the specialized knowledge questions in MMLU, the ones needing deeper understanding?
There, these same top configurations really excelled in what the researchers called scientific reasoning. They showed a much better ability to effectively synthesize complex, domain-specific information from the retrieved context. Their answers showed a deeper, more nuanced understanding and integration of the facts, not just spitting back retrieved sentences. It was more like coherent, informed reasoning based on the evidence provided.
That's the goal, isn't it? Not just getting an answer, but getting the most accurate, the most succinct, and the most relevant answer possible, delivered clearly and confidently. That really feels like the hallmark of a truly intelligent and reliable AI coach by Ian Nathu, that ability to take in vast amounts of information and distill it down into precise, trustworthy insights that actually help you. Okay, let's bring this all home. Synthesizing everything we've learned from this deep dive,
Right.
what are the absolute key takeaways? What are the levers that really move the needle when you're trying to enhance these retrieval-augmented generation systems?
I think the most impactful findings really point towards prioritizing smart, thoughtful design choices over just trying to scale everything up with brute force. The big ones are, 1, contrastive in-context learning is a game changer. That novel approach, explicitly learning from both correct and incorrect examples. It was the single most effective method they found for boosting ARGI performance, especially for specialized knowledge.
Right.
It fundamentally teaches the model to be more discerning.
Like that one really stood out. What's number 2?
2, focus mode is crucial for precision. Retrieving only the most relevant sentences, not just broader chunks, significantly improves the quality of the responses. It cuts through the noise and delivers highly targeted context. Surgical accuracy, essentially.
Makes sense. Precision matters.
3,
knowledge base quality over quantity. This came through loud and clear. The sheer size of your knowledge base, or even how many documents you retrieve per query, is much less critical than ensuring the information in that base is high quality, relevant, and well curated. A smaller, excellent library beats a massive, messy one.
Quality, relevance, curation. Got it. And the fourth key takeaway.
4. Prompt design remains paramount. How you instruct the AI model fundamentally shapes its entire behavior and performance. Clear, concise, helpful prompts are absolutely essential to guide the model effectively in using the retrieved information and generating accurate, useful answers. Your instructions are its compass.
Okay, those are the big 4 positive levers. And just as useful is knowing what didn't have as much impact or had unexpected effects so we don't waste time focusing on the wrong things. Exactly. We saw that LLM size, while generally helpful, offered diminishing returns, especially for niche tasks, so bigger isn't always proportionally better. Document chunk size, within the range they tested, made minimal difference, suggesting maybe less need for obsessive tuning there. Retrieval stride frequency had that surprising result. More frequent updates actually hurt performance, emphasizing the value of context stability sometimes. Simple query expansion offered only marginal gains in this study, and quite significantly, mixing languages in the knowledge base actually reduced performance in their setup, highlighting the challenges there.
So, pulling all this together, what does this research mean for you, our listener, as you think about using AI, maybe even building RG systems, in your own work or life?
Well, this research provides a really valuable data-driven roadmap. It helps steer you away from some common assumptions or potential pitfalls and points you directly towards specific techniques that have been empirically shown to enhance RG's accuracy, relevance, and efficiency. It really emphasizes smart design, careful curation, and testing advanced techniques over just scaling up components or throwing more raw data at the problem. It's about working smarter with your AI tools, ensuring that your AI coach is built on principles that lead to genuinely valuable and trustworthy insights.
Which brings up a really interesting question for all of us to ponder. As you consider integrating AI more deeply into what you do, how can you apply these kinds of insights? How can you help build or utilize an AI system that isn't just knowledgeable, but truly wise in its ability to understand context, retrieve the right information, and generate genuinely helpful, accurate output? How do we cultivate that wisdom in our AI tools? And that brings us to the end of our deep dive today. We've taken quite a journey into the sophisticated world of retrieval-augmented generation, haven't we? We've explored what really drives its effectiveness, from the fundamental architecture that gives AI these powerful research abilities, right through to cutting-edge techniques like contrastive in-context learning and that super precise focus mode. We've seen how these thoughtful, empirically tested design choices can transform an AI from just a generalist into a truly informed, accurate, and reliable specialist.
Yeah, it's really clear that the path towards more reliable, trustworthy AI heavily involves these kinds of intelligent retrieval and generation strategies, moving far beyond the limitations of just static, pre-trained knowledge.
Definitely. Now, here's a little provocative thought for you to take away and perhaps mull over. Imagine a future where RD systems don't just retrieve static documents based on the query you type in. Imagine they could dynamically adapt their entire retrieval strategy based on the subtle nuances of your question, the ongoing context of your conversation, maybe even your past interactions. What if they could almost anticipate whether you needed broader background context right now, or maybe laser-sharp detail on a specific point, fetching information in a completely fluid, adaptive, almost predictive way? What incredible new possibilities would that unlock for truly personalized learning, for knowledge discovery, for AI assistance that feels almost intuitive?
An assistant that understands not just the words you say, but the underlying need behind them in that moment, that's a powerful vision.
Exactly. So, in light of everything we've discussed from this research today, what's your practical action plan for maybe building better RG systems, or even just for using AI tools more effectively? Here are a few concrete steps based on the findings. 1. Master the prompt. Really invest time here. Craft clear, concise, helpful prompts. Guide the AI precisely toward its best performance. Remember how crucial those instructions are.
Foundational.
2. Curate your knowledge base. Prioritize quality, relevance, and maybe even good organization over just sheer volume. Think like a meticulous librarian building a focused collection, not just a data dump.
Quality over quantity, definitely.
3. Explore advanced retrieval techniques. Don't be afraid to investigate and, if possible, implement things like contrastive in-context learning, learning from right and wrong examples, and focus mode, retrieving only the most essential sentences. These novel techniques showed real power in boosting accuracy and precision.
That's where some of the biggest gains might be found.
And 4. Test and adapt. RAG isn't one size fits all. Continuously test different configurations.
See what works best for your specific tasks, your specific data. Embrace that iterative improvement cycle for your AI coach.
Absolutely. These insights we've discussed today are truly foundational for making AI tools, like the AI Coach by Anil Nathu, genuinely intelligent and reliable partners as you pursue knowledge or try to solve complex problems.
Thank you so much for joining us today for this deep dive. Visit the AI Coach website for more AI insights.